What if the headline everyone is sharing is built on one tiny truth and one giant misunderstanding? What if the object racing toward the inner solar system is real, but the part people fear most is not? Before we go deeper, do this with me. Tap like if you love real space mysteries, subscribe if you want facts without the hype, and share this with one friend who always sends you wild space headlines first. Because yes, 3i Atlas is real. Yes, James Webb really studied it. Yes, this object came from outside our solar system. And yes, it passed near the orbit of Mars. But no, it was not confirmed to crash into Mars. That part is the twist. The scary version is not the true version. And somehow, the true version is even more incredible. This is not the story of a simple collision. This is the story of a visitor older than Earth, older than our solar system, maybe older than almost anything humans have ever studied this closely. It crossed the dark space between stars for billions of years. Then, for one brief moment, it entered our neighborhood, lit up under the sun, and let our telescopes read a message written before our planet even existed. And the message was strange. So strange that once astronomers looked closely, they realized this was not just another comet with a dramatic headline attached to it. This was a chemical time capsule from a place we have never seen, from a star system we cannot point to, from an age of the galaxy we can barely imagine. Let's start with what 3i Atlas actually is. The name sounds technical, but it tells you a lot. The number 3 means this is the third confirmed interstellar object ever discovered passing through our solar system. The letter I stands for Interstellar. And Atlas is the survey system that first spotted it. That matters because out of all the rocks, comets, dust, and debris humans have tracked in the sky, only 3 confirmed visitors have been caught coming from outside our solar system. 3. Not 30, not 300. 3. That alone makes this object rare. But the moment scientists calculated its path, they saw something even bigger. It was not moving like an ordinary comet born around our sun. Its orbit was open, not closed. That means the sun could bend its path, but not keep it. 3i Atlas was not here to stay. It was falling inward, swinging past the sun, and then leaving forever. Think about what that means. Every normal planet, asteroid, and comet we know in our solar system belongs here in some way. They formed from the same giant cloud of gas and dust that made the sun, Earth, Mars, Jupiter, and everything else in our system. They are family. They share the same basic home story. 3i Atlas does not. It formed around another star. Maybe a star that still exists, maybe one that died long ago, maybe in a system colder, older, and stranger than ours. Then something violent happened. A giant planet may have thrown it out. A chaotic young system may have ejected it. And once it was gone, it began the longest journey you can imagine. No sunrises, no sunsets, no home planet below, just cold, darkness, radiation, and motion for billions of years. Now here is where people started turning a great science story into a panic story. 3i Atlas did make a relatively close pass to Mars, compared with the huge scale of the solar system. On October 3rd, 2025, it came closest to Mars at about 29 million kilometers away. That sounds scary only if you ignore how big space is. 29 million kilometers is not a near miss in the everyday sense. It is not a collision course. It is not a planetary emergency. It is a safely distant flyby that happened to be scientifically useful. That safe distance mattered. It meant spacecraft already near Mars could watch it. And they did. Mars orbiters looked at it. Instruments studied its coma, the glowing cloud of gas and dust around it. Even Perseverance, a rover sitting on the surface of Mars, turned its camera toward the sky and captured the first image ever taken from the surface of another planet, of an object from another star system. Stop and sit with that for a second. A machine on Mars photographed a comet from another star. If that does not make you feel small and lucky at the same time, I do not know what will. But Mars was only one chapter. The bigger chapter came when the most powerful space telescope ever built focused on this traveler. James Webb did not just take a pretty picture. Webb did what it does best. It pulled the object's light apart and studied the chemistry hidden inside it. This is where the story becomes much deeper than the title. Because when astronomers first see a comet, they usually expect certain ingredients to show up in familiar patterns. Water, carbon dioxide, carbon monoxide, dust. Maybe a few surprises, but still within a range that makes sense if the object formed in a system like ours. 3i Atlas did not behave like that. Webb and other observatories found chemistry that looked unusual from the start. It was rich in carbon dioxide compared with water. Later, Webb directly detected methane, and not just a little. The methane-to-water ratio was so high that scientists immediately understood they were looking at something with a very different birth environment from most comets in our own solar system. That matters, because chemistry is a kind of memory. A comet keeps a record of where and how it formed. If an object has more of one frozen gas and less of another, that can point to the temperature of the place where it was born. It can hint at how far it formed from its star. It can even hint at the age of the system that made it. So when Webb saw methane in 3I Atlas and saw that the ratio was far outside what we usually measure in solar system comets, scientists did not just say, "That is odd." They started asking a bigger question. What kind of place creates something like this? And that question led to an even more dramatic answer. The data suggested 3I Atlas may have formed in an extremely cold environment. Not just cold in the way deep space is cold. Cold in the sense that certain kinds of ice could survive in ways that tell us this object came from a system with conditions very different from our own. On top of that, Webb found unusual isotope clues too, including signs connected to heavy hydrogen and carbon that point to a very ancient origin. In plain English, this comet does not only seem foreign, it seems old, very old, possibly around 10 to 12 billion years old. Let that sink in. Earth is about 4.5 billion years old. Our solar system is about 4.6 billion years old. If the estimate is right, 3I Atlas formed billions of years before the sun was born, before Earth had oceans, before dinosaurs, before life, before our planet existed at all. This object may have already been traveling through the galaxy when the material that would become Earth was still scattered across space. That is the real shock in this story, not impact, not destruction, not Mars exploding in a cloud of dust. The real shock is age. The real shock is origin. The real shock is that something ancient and alien in the most literal scientific sense drifted into view long enough for us to inspect it. And it gets even more emotional when you think about how unlikely that moment was. The Milky Way may be full of interstellar debris. Every young solar system throws things out. Giant planets shift, tug, and sling smaller objects into deep space. Some get locked into distant clouds. Some get ejected forever. Over billions of years, the galaxy becomes full of these frozen leftovers wandering between stars. But they are dark, tiny, cold, almost impossible to see unless they get close to a star and start to warm up. That means most interstellar objects pass unseen. We only notice the lucky few that arrive at the right angle, at the right time, bright enough for our instruments to catch. So when 3I Atlas appeared, the race began immediately. Telescopes on Earth turned toward it. Telescopes in space turned toward it. Missions built for totally different purposes made room to observe it. Scientists knew this was a one-time chance. This object was not going to circle back in a few years. It was not going to wait for better weather. It was not going to slow down for us. It came in fast, rounded the sun, and kept going. That urgency is part of what makes the story so gripping. Every observation had to count. Every hour mattered. If you miss a comet from our own system, you might get another chance decades later. If you miss an interstellar object like this, that chance is gone forever. And still, despite that pressure, the science teams delivered. They tracked its path. They pinned down its motion. They confirmed it posed no threat to Earth. They used Mars-based observations to improve where it would be seen next. They studied the gases coming off it. They watched how its activity changed as it moved away from the sun. And James Webb gave us the strongest clues of all about where this object may have come from. Here is what I love about this part of the story. The truth did not get smaller when the collision rumor fell apart. The truth got bigger. Because fear is easy. Fear grabs attention fast. It might hit Mars is a fast headline. Your brain reacts in 1 second. But this object may carry chemical evidence from a star system born during an earlier age of the galaxy. It takes longer. It asks more from you, and yet that second version is the one worth your time. That second version is the one that can actually change how you see the universe. If you are still with me, here is your mission. Hit subscribe for the stories that stay true after the hype dies. Leave a like if you want more real cosmic drama. And send this video to someone who thinks science gets boring when the clickbait ends. Because the clickbait ending would be simple. Near miss. Big headline. People argue for a week. Then everyone moves on. But the real ending is not simple at all. The real ending asks us to imagine the galaxy as a place with memory. Not just stars and planets, but wandering fragments that preserve chemical records from worlds we will never visit. 3I Star Atlas is one of those records. It is a sample from somewhere else, delivered for free by gravity and timing. No human-made probe has ever traveled to another star system and brought back a frozen piece of it. 3I Atlas came to us. That does not mean we could catch it. We could not. It was moving far too fast. By the time the world understood what it was, the only thing we could really do was observe, measure, and learn. No spacecraft we have right now could simply chase it down and match its speed. So the information in its light became priceless. This is why James Webb matters here so much. Webb is not just powerful because it sees faraway galaxies. It is powerful because it can read faint chemical fingerprints in space with incredible sensitivity. When 3I Atlas warmed up enough for its ancient ice to escape into space, Webb could study that released gas and tell us what kinds of molecules were there. Imagine reading the smoke from a fire to learn what kind of wood was burning, where it was cut, and how long it had been stored. That is not exactly what astronomers do, but it is close enough to feel the power of it. They are not guessing from a vague blur. They are reading clues hidden in light. And those clues told them this comet was unusual in more than one way. Methane was one of the biggest headlines in the science itself, because methane is extremely volatile. In simple terms, it does not like to stay put when warmed. So if Webb saw direct methane gas from an interstellar visitor, that means the comet preserved it deep enough. That alone tells us something about the comet's structure. But the bigger point is how much methane there was compared with water. That ratio helps scientists compare this object with comets from our own solar system. And 3I Atlas stood out hard. Not a tiny difference, not an edge case. A real signal that said this object likely formed in a different chemical setting. Then there were the isotope clues. Heavy hydrogen, also called deuterium, showed up at levels that do not match what we usually see in solar system comets. Carbon clues pointed toward an origin from a much earlier time in the galaxy, before later generations of stars changed the chemical mix more fully. This is the kind of detail that sounds small until you realize what it means. It means 3I Atlas is not just from another place. It may be from another era, an older Milky Way, a younger universe, a time when star formation was roaring at a much higher rate than it is now. So the object in this story is not exciting because it threatened a planet. It is exciting because it survived history, billions of years of it. It survived whatever chaos threw it out of its birth system. It survived the deep freeze between stars. It survived cosmic radiation. It survived a journey so long that entire stars lived and died while it kept drifting. And then it passed through our system during the tiny slice of time. When humans happened to have built instruments smart enough to understand what they were seeing, that part honestly feels almost impossible. We talk a lot about how huge the universe is, and that is true, but size alone can make space feel empty and distant. Stories like this do the opposite. They make the universe feel connected. Something born around another star billions of years ago ended up speaking to us through chemistry. Not with words, not with signals, not with intention, but with evidence. And evidence is enough. Now, if you have seen people online saying James Webb confirmed a Mars collision, here is the clean answer you can keep. Webb confirmed important chemical details about 3I Atlas. It did not confirm a crash into Mars because there was no crash to confirm. The comet passed Mars at a safe distance. The real discovery was not impact risk. The real discovery was what the comet is made of, how strange that chemistry is, and what that chemistry may say about its birthplace. That distinction matters, especially now. We live in a time when one dramatic sentence can outrun the careful truth in minutes. The scariest version spreads first. The accurate version arrives later, quieter, and often gets less attention. That is exactly why stories like this need to be told well. The truth should not have to lose just because it takes 10 more seconds to explain. And honestly, it should not lose here, because the truth is cinematic, a lonely traveler from another star system, an ancient body older than the sun, a safe pass by Mars that lets robots and spacecraft watch it, a world-class telescope detecting methane and strange isotopes, scientists realizing they are looking at one of the oldest objects ever closely studied. And then, just as quickly, the visitor is gone. If you wrote that as fiction, people would say you overdid it. But there is still one more layer that makes this story bigger than one comet. 3I Atlas is also a preview. It tells us what the next decade of astronomy may feel like. For a very long time, interstellar objects were mostly an idea. Scientists expected them to exist, but expectation is not the same as observation. Then came the first confirmed one, then the second, then 3I Atlas. And now sky surveys are getting better, faster, more sensitive. Better at catching faint motion against huge fields of stars. That means this may not stay rare forever, not common in the everyday sense. These are still extraordinary discoveries, but less impossible than they used to be. Future observatories will likely catch more visitors earlier. That gives scientists more time to observe them before they vanish. One day, if we are lucky and prepared, we may even send a mission to intercept one. Think about how huge that would be. Not a rock from our cosmic backyard, not a comet from the familiar family of our solar system, but a direct encounter with material formed around another star. That is not science fiction anymore. It is a planning problem, and planning problems eventually become missions. So 3I Atlas is not only a mystery solved in part, it is also a rehearsal. A warning, yes, in the sense that we need to track fast-moving objects well, but even more than that, it is an invitation. Build better tools, watch the sky harder, be ready next time. Because there will be a next time. Somewhere out there, right now, another interstellar object is drifting through darkness. Another frozen witness from another system is crossing the galaxy without caring whether anyone notices. Maybe it will never come near us. Maybe it already did and we missed it. Or maybe one day soon it will enter our sky, brighten, and give us another short chance to learn. Quick pause before the final stretch. If this video changed how you see this headline, share it with one person who loves space but hates misinformation. Subscribe for more stories where the facts hit harder than the rumors, and tap like so more curious minds find this side of YouTube. Because in the end, the biggest lesson here is not just about a comet, it is about attention. What do we choose to notice? The false alarm or the deeper wonder? The loud claim or the lasting fact? The fear of destruction or the awe of discovery? 3i Atlas gave us that choice in real time. A lot of people saw collision course and stopped there. But if you stay a little longer, the universe gives you something much richer. It gives you perspective. Mars was never the real target of this story. We were. Not physically, mentally, emotionally, intellectually. This object challenged us to grow up a little in how we talk about space. To stop needing every cosmic story to become a disaster movie before we care. To realize that knowledge itself can be dramatic when you understand the stakes. Because what are the stakes here, really? The stakes are that we are finally learning to read the history of places we cannot visit. The stakes are that our telescopes are becoming sensitive enough to compare our solar system with others through actual physical evidence. The stakes are that every interstellar object may carry clues about how common or rare the ingredients for life might be across the galaxy. That last part matters more than it may seem. When scientists study odd chemistry in an object like 3i Atlas, they are not only collecting trivia about one comet, they are slowly building a map of what kinds of star systems exist, what kinds of frozen material they create, and how different their chemistry can be, and whether the ingredients that matter for planets and maybe life show up often or only under special conditions. In other words, this is part of a bigger question. Are we normal? Is our solar system typical? Are the chemical conditions that shaped Earth common? Or did we grow out of a rarer story than we think? A single comet cannot answer that alone, but it can give us a clue. And sometimes a clue is enough to change the next 10 questions scientists ask. That is why James Webb looking at 3i Atlas matters far beyond one news cycle. This was a serious look at a messenger from elsewhere. And the messenger did not arrive empty-handed. It arrived carrying methane. It arrived carrying strange ratios. It arrived carrying evidence of deep cold and great age. It arrived carrying a reminder that our solar system is not the whole story. Then it left. There is something almost heartbreaking about that. We got one pass, one encounter, one brief window where sunlight warmed its ice enough for us to learn from it. Now it is already heading back out, farther and farther away, beyond the planets, beyond the easy reach of our tools, back into interstellar dark. Someday it will pass beyond the edge of our solar system and continue drifting through the galaxy like it did before we ever existed. And yet, for one moment, we were here. We saw it. We measured it. We understood at least part of it. That is a victory, not over danger, over ignorance. And that may be the most human kind of victory there is. So when you see this title again, remember the deeper truth hiding inside it. James Webb did confirm something extraordinary about 3i Atlas. Just not the part built for panic. It confirmed that this object is chemically unusual. It confirmed that it preserves clues from a very different birthplace. It confirmed that the galaxy still has ancient secrets drifting through it. And it confirmed that when those secrets pass by, we are finally smart enough to listen. That is the story worth remembering. Not that Mars almost got hit, but that humanity almost missed how amazing reality already was. And maybe that is the best ending possible. The universe did not give us a crash. It gave us a message, not in language, but in light. Not in warning, but in evidence. A message from a time before the sun carried by ice, dust, methane, and motion across billions of years. We read part of it. And because we did, the night sky is not just a little brighter. It is deeper. If you want more stories where the real universe turns out stranger, older, and better than the rumor, subscribe now and share this video with your smartest friend. Like it, so this kind of careful wonder can beat empty hype for once. The next interstellar visitor is out there somewhere. And when it arrives, the question will not just be what it might hit. The real question will be this: what truth from another star will it bring with it next?